Okay, in the last segment, what we did is we derived the equation that enables us to compute the system derivative to a control volume formulation, basically the time derivative. And we looked at deriving this for inextensive or intensive properties expressed as being the extensive property. This is what the equation would be. So with this equation, on the left-hand side, what we have is something that relates to the time rate of change of our extensive properties for a system. So it's important to note that that is for a system. And then the first term on the right-hand side, what this is, it's the time rate of change of our extensive property n in the control volume. And so it's important to note that that's in the control volume. And then the last term is the net rate of flux of that property into or out of the control volume. And this is with respect to the control surface. So what we have system, and then we have a volume integral, and we have a surface integral, and the volume and surface integral pertain to the control volume. And so this relationship then, what it does is it relates our system to the control volume. And the utility of having this relationship is that it enables us to apply the basic laws, and remember the basic laws only apply to fixed mass systems, to control volume, where you have mass crossing the boundary, which is typically what we have in fluid flow. So what we're going to do now in the next couple of segments is we're going to look at applying this equation, starting with the most basic, and we'll start with the conservation of mass or the continuity equation.